Right. So 10.3, calculus in polar coordinates. Calculus, this word means derivative and integration. That's what you learned so far. Everything is integration and derivative. Okay. All right. So this is what calculus, right? So the first thing you need to know is slope. Right? What's slope? Slope is derivative. Slope is derivative. Okay? So first thing to do first, slope. Slope means derivative, really. All right. So suppose I have given a curve in polar coordinates, and a curve in a polar coordinate always looks like this: r equal to a function of theta. It always looks like this. R equal to f, always like this. Okay, now what's the slope, right? The slope, right? In the definition you have learned before, is dy dx, right? This is in Cartesian coordinates. In Cartesian coordinates really those x, y. And this is x, y. Okay, that's dy dx. Now, what we want to do right now is we want to change this. We want to change this into r and theta. Change it into r and theta. So how do we do this? How do we do this one? Okay. All right. So we recall the relation between x, y, and r theta. Namely, x is r cosine theta, y is r sine theta. Okay. Right. Okay. So therefore, so what is this? So what is this? So I'm going to substitute this into this. Okay? All right. So slope, which is dy over dx. I'm just going to divide both numerator and denominator by d theta. So this is derivative of y with respect to theta, and this is derivative of x with respect to theta. Okay. So what is y? Y is r sine theta. Okay. Y is r sine theta. What is x? X is r cosine theta. Okay. X is r sine theta. Y is r sine theta. X is r cosine theta. Okay, so what is the difference? So how do I differentiate this? Well, this is the product of two functions. One is r, one is sine theta. And r is f of x. Okay, so let me replace r by f of x first. E d theta. F of theta times sine theta. And this is, denominator is r is f of theta cosine theta. Right? So I'm going to do this derivative, and I'm going to use a product rule. Product rule means you differentiate the first function with respect to theta. So f prime of theta times the second function plus the first function times the derivative of the second function, sine, derivative of sine, cosine. Then for this one, derivative, again, product rule. Derivative of f, derivative of first function times second function, then plus first function times the derivative of second function. Derivative of cosine is negative sine. Okay, derive cosine. Yeah, derive on this f of theta and derive cosine, which is negative sine. Okay, so that's all I have. So this formula is the theme 10.2 on page 733. This formula, the slope is equal to this. When the curve is given by this, that's slope. So let me just show you this statement, okay? Let f be a differentiable function at theta, the angle. The slope of the line tangent to the curve r at the point f theta, f of theta is equal to this. And this is exactly the expression I had here. Exactly the expression. So calculus means derivative and integration. So that's a derivative. The integration. So next is integration. So this is 2. Okay. So I have so I have a so given a curve r equal to f of theta. Okay, given a curve in polar coordinates. Maybe okay, this curve is described by r equal to f of theta for some function f. Okay, now if I draw this picture, okay, this graph say from here. Okay. This is r equal to f of theta. Okay, this curve. Okay. And then the question is, suppose this angle is alpha, this angle is beta. Okay, so from here to here is alpha, from here to here is beta. So theta is between alpha and beta. Okay. The angle theta is between alpha, at least alpha, at most beta. So this, okay, so this curve is this piece. The question is, what is the area of shaded region? That's the question. So let me from here. What is this area? Okay, that's what we want to know. Okay. All right. Now, if we use the if we use the the following things, okay. So how do we do the integration? The idea is the following. Suppose I have a sector. If I have a sector like this, okay, and suppose this is a curve, and this is alpha, and this is beta, from here to beta, and this is a sector, namely this is a circle, it's a part of the circle. The question is, what is this? So let me say call this is R. Okay. So suppose I have a circle. radius is r. Okay. Now, what is the area of this sector? Area of this one. Now, if we can solve this one, we can solve this one. So we need to solve this one first. Okay, I have a circle with radius r, and I have a piece just like a pizza, a slice of pizza. Okay, pizza is alpha is beta angle, and okay, and I want to find out. And if I know the radius or the diameter of the pizza, and if I know what this area, this angle, I can determine the area of that pizza, that piece of pizza. Okay, think of this as a pizza. Okay, this is nice. Okay, so how do I determine the area like this? Well, this is very simple. If this is a circle, it's very simple. Why? Because it's all proportional. For a circle with radius r, the whole circle, right? Whole circle is the area. The area is, we all know that, right? It's what? Pi r squared. Right? As you know it from geometry. It's pi r squared. But right now I only have a slice. This is a small slice, and this angle is okay. This is alpha. This is beta, right? So it is this angle. This angle. So let me call it. So let me let delta theta to be beta minus alpha. Okay. So is this angle. So how large is this one? Well, it's all proportional. So the area of the slice, of this slice, let me call it AOB. This particular slice is equal to a proportional. Okay, so it is. So if it is the whole thing 2 pi, it will be pi r squared. But right now I only have this little angle. So that's the area of the slice. Which if I can cancel the pi, it's r squared over 2 delta theta. This is how large this one is. But this is for a circle. What we have right now is this is not a circle. This is an irregular shape. So how do I convert this into do a problem like this? It's very simple. We almost directly translate into this. So for this graph, I'm going to just draw this picture. Okay. So for this graph, this is r equal to f of theta. Okay, and this is alpha. This is beta. And I want to find this area. This area is equal to, okay, almost, it's very similar to this, but we have to do it, we have to use integration. So this is equal to integration 1/2. R is f of theta, so f of theta squared, this is r. This d theta now, delta theta now is d theta. It's from alpha to beta. So this is very similar. This is very similar to this. But the only difference is that right now I have an irregular shape.